Hello everyone. Today we are going to see about the impulse invariant method, which is one of the methods used to convert an analog transfer function into a digital transfer function. Okay, so given it is the question for the analog transfer function h of s is equal to 2 by s plus 1 into s plus 2, determine h of z using impulse invariance method. Assume capital T, that is the sampling period, is equal to 1 second. So here they have given the analog transfer function. Normally the analog transfer function is represented by h of s. So s implies that it is a analog in nature. Okay, and if we convert this h of s into h of z using this impulse invariance method, you will be getting the digital transfer function, which is h of z. Okay, solution. Given h of s is equal to 2 by s plus 1 into s plus 2. So listen, you have to write the denominator in the power whose power of s should be 1. Okay, here the s power is 1, and here also in the second term also the s power is 1. Only then you can apply this partial fraction method. So using partial fraction method, we can write h of s is equal to a by s plus 1 plus b by s plus 2. So since the power of s is equal to 1, here in the numerator, we are having only the constant. Supposing if it is s square, then you will be getting as plus b, like that. Okay, so before that, we have to convert the h of z, that is h of s, the analog transfer function denominator should be in the power of s. That is the power of s should be 1. Okay, like that you have to convert any analog transfer function into a transfer function whose denominator should contain the s terms, whose power should be 1. Okay, now h of s is equal to a by s plus 1 plus b by s plus 2. Now we need to find the constants a and b. So to find a, what you have to do is the denominator of a is s plus 1. So multiply h of s into s plus 1, and now substitute s is equal to minus 1. So s plus 1 into, we know that h of s value is 2 by s plus 1 into s plus 2. So here this s plus 1 terms will get cancelled, and now we have to substitute s is equal to minus 1. So 2 divided by minus 1 plus 2, which is equal to 2 by 1. So a's term is 2. And now we need to find b. So b is equal to, the b's denominator is s plus 2. Okay, so you have to find b like this. That is, b is equal to s plus 2 into h of s, where s is substituted by minus 2. Okay, now s plus 2 into h of s value is 2 by s plus 1 into s plus 2, and substitute s is equal to minus 2. So here this s plus 2 and s plus 2 terms will get cancelled, and now substitute s is equal to minus 2 in the remaining terms. So 2 divided by minus 2 plus 1. So 2 divided by minus 1, which is minus 2. So b is equal to minus 2 and a is equal to 2. Now hence h of s can be written as a's value is 2. So 2 divided by s plus 1, and b's value is minus 2. So it is minus 2 by s plus 2. Here we have two poles. See, normally in any transfer function, we'll have the poles in the denominator. Okay, so here we have two poles. So what are they? So this term can be written as s of minus of minus 1. Okay, and similarly this term can be, that is s plus 2, can be written as s minus of minus 2. So here I'm having two poles. What are they? One pole is minus 1 and another pole is minus 2. So P1 stands for pole 1, which is minus 1, and P2 stands for pole 2, which is minus 2. So I'm having two poles. So now we are going to apply the impulse invariance technique. So if h of s is given as summation k varies from 1 to n, c suffix k, ck by s minus pk. See, listen, here this k represents the number of poles. Okay, so the number of poles can vary from 1 to n, and c represents the constant, and s minus, this is pk, represents the poles. Then supposing if h of s is like this, that is summation of k varies from 1 to n ck by s plus pk, then h of z can be written as summation of k is equal to 1 to n ck by 1 minus e power pk into t z inverse. That is, this term, that is s minus pk, is transformed. This is the denominator term. Only this denominator term changes, right? That is, s minus pk is transformed to 1 minus e power pk into t into z inverse. So here I'm having two poles, that is p1 and p2. So k value is 1 and 2. So since we have two poles, that is h of s is equal to 2 divided by s minus of minus 1 minus 2 divided by s minus of minus 2. See, listen, this is written as summation of, okay, summation of, see here, this is like this, summation of k varies from 1 to 2. ck divided by s minus pk. Okay, so h of s is like this. Now we need to convert it into h of z. So s minus pk. So this is s minus p1 and this is s minus p2. So it is transformed to h of z is equal to 2 divided by 1 minus e power minus 1. Okay, minus 1. Instead of pk, we have to substitute minus 1 t z power minus 1 minus 2 divided by 1 minus e power minus 2. So instead of pk, you have to substitute minus 2 t into z inverse. So in the problem, it is given that t value is 1 second. So substitute h of z is equal to 2 divided by 1 minus e power minus 1 z inverse minus 2 divided by 1 minus e power minus 2 z inverse. Okay, so you need to find out the value of e power minus 1 in the calculator. Okay, so 2 divided by 1 minus e power minus 1's value is 0.3678 z inverse minus 2 divided by 1 minus e power minus 2's value is 0.1353 z inverse. Okay, now what we have to do is we have to take the LCM. So LCM is 1 minus 0.3678 z inverse into 1 minus 0.1353 z inverse. So in the numerator, you just cross multiply. So this two term is multiplied by 1 minus 0.1353 z inverse minus 2 into this term, that is 1 minus 0.3678 z inverse. Now multiply. So 2 into 1 is 2 minus 2 into 0.1353 z inverse is 0.2706 z inverse minus 2 into 1 is minus 2, minus into minus plus 0.3678 into 2 is 0.7356 z inverse divided by 1 into 1 minus 0.1353 z inverse into 1 is minus 0.1353 z inverse, and again minus 0.3678 z inverse into 1 is minus 0.3678 z inverse. Then minus into minus is plus 0.3678 z power minus 1 and 0.1353 z power minus 1. When you multiply these two terms, you will be getting plus 0.0497 z power minus 1 into z power minus 1. So what you have to do is you have to add the that is power terms. Okay, z power minus 1 plus z power minus 1, you will be getting z power minus 2. So here this 2 term is cancelled. That is 2 and minus 2 will get cancelled. So here when you subtract this 0.7356 and 0.2706, you will be getting 0.465 z inverse divided by 1. And when you add these two terms, that is 0.1353 and 0.3678, you will be getting minus 0.503 z inverse plus 0.0497 z power minus 2. So the digital transfer function h of z is equal to 0.465 z inverse divided by 1 minus 0.503 z power minus 1 plus 0.0497 z power minus 2. Thanks for watching the video. Thank you so much.